The next miscellaneous equation we'll be solving are equations containing rational exponents. Now before we start solving a lot of those, I'd like to review a little bit from intermediate algebra. Notice that a to the rational exponent m over n, the rational means fraction and there's a fraction in the exponent, so we have a to the m over n, is the same thing as the nth root of a to the m, which is also the same thing as the nth root of a, all raised to the mth power. This can help us when we have a rational exponent we're trying to simplify it. Here's two examples. 27 to the 2/3. Now some of you may not be able to do that in your head, but we can rewrite it as the cube root of 27 squared. We all know that the cube root of 27 is 3, and 3 squared is simply 9. So 27 to the 2/3 was very easy to solve when we rewrote it in radical form. 16 to the 3/4 will be reduced the same way. The 4 in the denominator is the same as the index of the radical symbol. So we have the 4th root of 16 cubed. I like to do the root before I cube it. I could take 16 and cube it, but that's going to be a very large number and not something I want to do in my head. The 4th root of 16 is simply 2, and 2 cubed is 8. So that's just a little bit of review from intermediate algebra. Also, we will do some solves that we've already covered in intermediate algebra as well before we actually talk about the rational exponents. If I'm trying to solve this x squared equals 9 using the square root method, I can just take the square root of both sides and I'm getting x equals, don't forget your plus or minus whenever you take the square root of both sides of an equation. Similarly, I can do this on the problem below. When I take the square root of both sides, I'm getting x equals, in this case, plus or minus 3i. Now let's come over here and work on the cubes. X cubed equals 8. In order to get rid of the cube, I'm going to take the cube root. And when I take the cube root of both sides, I'm left with x equals 2. Do I need to put a plus or minus here? Well, the answer is no. I only put a plus or minus when I'm taking an even root of both sides. Here I'm taking the cube root, which is an odd root, and I do not have to take the plus or minus. What happens when the 8 is negative? When I take the cube root here, I have x equals, well, what is the cube root of negative 8? Well, you can take cube roots of negatives. The answer is just negative 2. And the reason is because negative 2 cubed, which means negative 2 times negative 2 times negative 2, is negative 8. So that actually does work. Negative 2 cubed is negative 8. So this is the answer. Notice on the left side, on the red equations that we solved, because they were square roots, we had to put plus or minus. Also, when you take the square root of a negative, you get an I. Whereas on the right-hand side, because both of the green problems have cubes, when you took the cube root, you do not put plus or minus. Similarly, when you solve rational exponent problems, you'll have some being plus or minus and some not being plus or minus. I'm going back to our original x squared equals 9. Another way I could have solved x squared equals 9, instead of taking the square root, I could have raised both sides to the 1/2 power. The 2 and the 1/2 are reciprocals, and when they multiply out to 1. So we have x to the 1, or really just x, equals 9 to the 1/2. Well, 9 to the 1/2 is simply 3. But because I had a 2 in my denominator here, that's like the square root. So therefore I have to put a plus or minus here. Similarly, below, when I raise both sides to the 1/2, because the 1/2 exponent is the same as the square root, I have to put a plus or minus here. Because that denominator right there is even, I have to put a plus or minus, and I still get 3i. Notice that these answers are the same. This is just another way of thinking about it, which is going to help us when we're working on rational exponent equations. Let's take a look at these green equations over here. X is being raised to the 3rd power. To get rid of the 3rd power, instead of taking the cube root, which is an acceptable form, I could take both sides to the 1/3 power. And when I take one side to the 1/3 power, I'm getting 2, because 8 to the 1/3, remember, is really just the cube root of 8. Do I have to put a plus or minus here? Well, the answer is no, and the reason the answer is no is because that 3 is odd. Whereas on the other side, the 2 was even, so I have to put a plus or minus there. Same thing below, I'm going to take the 1/3 power here. And that leaves me with x equals, again, -2. I don't have to put plus or minus, I'm just taking the -8 to the 1/3, which is equal to -2. So that was just a little introduction so that we could solve rational exponent equations. On this next section, solving rational exponent equations, we have the most simple form, x to the m over n equals k, that we're trying to solve, or x could also be an expression inside the parentheses to the m over n equals k. So the first thing I would like to do is isolate the expression with the rational exponent. Next, I'm going to raise both sides to the reciprocal of the exponent, or in this case, n over m. Just like I did when I was taking the square root, instead of taking the square root, I took to the 1/2 power, or instead of taking the cube root, I took to the 1/3 power. I'm taking the reciprocal so that they could multiply out to 1. So if the numerator of the exponent, or m, that is of the original equation, is even, then we're going to need a plus or minus sign. The evens have plus or minus, just like when we took square roots we need plus or minus. When the numerator is even, we're going to need plus or minuses. If the numerator of the exponent, or m, is odd, then do not put a plus or minus sign. Do not. Next, you must check your solutions and eliminate any extraneous solution. Extraneous means that the solution that you got did not work. See that word extra in extraneous? That means the solution was not valid. Over here we have x to the m over n. This is just a little chart I try to help you remember here. If this m is even, notice the m, when we take both sides to the reciprocal, the m ends up being on the denominator and we have to put the plus or minus. Although if the m is odd, again, it shows up here on the denominator when we take the reciprocal exponent of both sides. We do not take the plus or minus if m is odd. Here's two very simple examples before we get to the more interesting examples down below. I have x to the 3/2 equals 27, so I would like to raise both sides to the 2/3. The reason I'd raise it to the 2/3 is because the 3/2 times 2/3 is really x to the 1. Although we really don't usually write x to the 1, so I'm just going to go ahead and erase that. Equals, do I have a plus or minus or not? Well, looking at the original equation's numerator, the original equation's numerator, is that even or is that odd? Well, it's odd, so I have no plus or minus here. Therefore, the answer is just going to be 27 to the 2/3, but I have to reduce that, which is the cube root of 27 squared. The cube root of 27 is 3, and 3 squared is 9. So my solution is 9, although I have to check my work. In order to check, I'm going to plug 9 into x. 9 to the 3/2 is supposedly equal to 27. I put the little question mark there because you don't really know if it's equal or not. We're checking. So this is the square root of 9 cubed, and the square root of 9 is 3, and 3 cubed is 27, so that this does check out. On the next problem, looking at the numerator, even before I start the problem, I can look at the numerator of the exponent and identify that this numerator is even. And because the numerator is even, that tells me I will have a plus or minus in this problem. So when I raise both sides to the reciprocal, in this case the reciprocal is 3/2, I'm left with x to the invisible 1, I'm not going to write the invisible 1, equals plus or minus. You have to put the plus or minus on the immediately next step. Some people try to put the plus or minus at the end of the whole problem, which can often cause mistakes. X equals plus or minus in the next step, 4 to the 3/2. Now I have to reduce 4 to the 3/2. 4 to the 3/2 is the same as the square root of 4 cubed, which is 2 cubed. or 8. So I believe my solution is plus or minus 8. Although I have to check both. When I check, I plug the value that I'm checking into x. X to the 2/3 is supposed to be equal to 4. Well, the cube root of 8 is 2, and 2 squared is 4, and that does work. Similarly, negative 8 to the 2/3, I put it in parentheses to remind you that the negative is part of the base. So that's a required, you have to put the parentheses there. The cube root of negative 8 is negative 2, and negative 2 squared is positive 4. So this does check out. Both of the solutions here do work. Here are some more examples that are a little bit more complex. Instead of just having x to the m over n, I have an expression to the m over n. I would like to isolate that expression with the rational exponent. I need it all by itself. So I first need to get rid of the minus 1. I'm going to add 1 to both sides. And now my expression is isolated. Next, I'm going to raise both sides to the reciprocal. Now, do I have a plus or minus or not? Well, I'm going to look at the numerator of the original problem, either the original problem here or the numerator over there. Is the numerator even or odd? Well, in this case, 3 is odd. Therefore, I have no plus or minus. This reduces to x squared minus 3x plus 3 equals no plus or minus because my numerator is odd. 1 to the 2/3. Well, that's a nice thing because 1 to the anything is always 1, so that's really easy. In this case, I have a quadratic equation left, so I'm going to set it equal to 0 and use one of the 4 methods that we discussed to solve. The first method I always try is to see if I can factor. It looks like this is going to factor minus 2 minus 1, and then I can get my solutions fairly quickly by using the zero product property. My two solutions are x equals 1 and x equals 2. Now before I move on to the next problem, I need to make sure that both of those solutions work. Sometimes one of the solutions works, sometimes the other solution works, sometimes neither of them work. So we're going to have to check them independent of each other. I'm going to come over here so I don't have to scroll down. First, I'm going to check x is equal to 2. So when I plug in 2, I'm getting 2 squared minus 3 times 2 plus 3, which reduces to 4 minus 6 is negative 2. Negative 2 plus 3 is 1. 1 raised to the 3 halves is still 1. And 1 minus 1 is 0. This does check. So x equals 2 is a valid solution. Next, let's check x is equal to 1. When I reduce on the inside, 1 squared is 1, minus 3 is negative 2, negative 2 plus 3 is positive 1, and we have the same result. 1 minus 1 is 0, and it does check. So both of these solutions check. Please be sure to check all your solutions for the rational expression equations. You are required to check because sometimes you get extraneous solutions. I will be telling you all year long whether you need to check or if it's an optional check. In this case, this is a required check and you have no choice, you do have to do it. Let's take a look at the next one. Notice that in my original problem, the 2 is even. What does that tell us? Tells us that we're going to have a plus or minus, and we're going to have a plus or minus on the immediately next step after you take the reciprocal power of both sides. Notice that my expression raised to the fractional exponent or rational exponent is already isolated. So next I'm going to raise both sides to the 3/2. So that leaves me with x plus 5 on the left-hand side equals plus or minus. Notice I put the plus or minus in the immediately next step. 4 to the 3/2 is the same thing as the square root of 4 cubed, which is 2 cubed, or 8. But the plus or minus has to go immediately next. To solve for x, I need to subtract 5. And I get -5 plus or minus 8. Now I have to continue to solve that because I actually know what -5 plus 8 is and -5 minus 8. So -5 plus 8 is equal to 3. -5 minus 8 is equal to -13. So these are my two potential solutions. I say potential solutions because I am required to check to make sure that both of them work. First I will check x equals 3. Plug 3 in every time you see x in the original equation. And I hope that this equals 4. I put a question mark because I'm not sure. So I have 8 to the 2/3 is supposed to equal 4. The cube root of 8 is 2, and 2 squared does equal 4. Okay, this actually does check out, so 3 does check. Next, let's check x is equal to -13. -13 plus 5, all raised to the 2/3, is supposed to equal 4. -13 plus 5 is -8. The cube root of -8 is -2, and -2 squared is 4. And this does check out as well. So both of those are valid solutions.